Yeah, yeah. Another thing I've been thinking about, we've got strong rules and regulations about what you do with dead animals. We're not allowed to bury them and all the rest of it. This circular economy, we should be doing it. We should be, disposing of them or burying them here. When I was in Canada with SEC, when I was doing my master's, we went to a farm and they disposed of their dead cattle, and they were finishing cattle. They weren't breeding cattle, but I mean, finishing cattle are almost as big as a cow is. So, but anything they had dead, they put it on a bed of sawdust and covered it over with more sawdust and left it for a year, and then went back. And the sawdust that, the thing had gone, bones and all. And then they spread the sawdust on the ground.
Yeah, basically, composting, is something that is used in the States. They've got they've adopted these rotary composters. So it's for big farms, with where they do have a high mortality rate.
Yeah.
And so it's in vessel composting, where they basically will put whole carcasses of pigs and cattle and whatnot.
Mm.
There are, I've come across, this is going back a few years, I've come across smaller on-farm systems for chickens. So for instance, when you've got a chicken farm, then they would basically have a box.
Mm-hmm.
And they would basically layer the chickens, layer wood chips, layer the chickens, wood chips, and just basically have another in-vessel system that way. Yeah. Basically anything that these animals are a high nitrogen addition to this compost pile.
You're losing a lot of nutrients by shipping that off farm.
Yeah.
Mm-hmm.
Exactly. This cow has accumulated all of that nutrient.
Mm-hmm.
So it would be a good addition back to the soil. Just like that with animals.
I don't think the authorities would like it.
Yeah, I mean, they always will talk about we need to basically be able to prove that none of the pathogens that normally would be a danger to your cattle would survive the composting process.
Yeah, they would. Yeah, they'd want you to be very careful that it hadn't died of anthrax or something.
Mm-hmm.
Yeah. Uh-huh.
And then that way, if that can be demonstrated, then usually the in-vessel composting is much more thorough, because even with hot composting, you could have a chance that the external side of something from the body will sort of end up on the outside, never goes through the hot center, and the pathogens don't get killed. And so It's the in-vessel composting that gives you that peace of mind. So yeah, so
that's the one that's rotated.
Yeah, I mean, it doesn't have to rotate, actually, rotate. It just has to be in vessel where basically you have the entire volume of that, vessel has got the same sort of high temperature.
Right.
So, there are big composting facilities in the country, they'll have container-sized vessels. And so it literally are containers that are built to keep that temperature and they don't rotate at all. It's just basically material pushed in and taken out.
Right. So when you're doing that composting of any composting and there's bad bugs in there and it gets hot, it kills them. Does it not kill all the good bugs too?
Pretty much. There are some bugs which, it depends on the temperature. It depends on the ramp up of the temperature as well. That's, a lot of the good bugs will simply create forms which will allow them to survive these conditions. But, if you...
Do they insist?
Yeah, I mean, that's one of the words, yeah.
The bad ones can't do that. How has nature arranged that?
Good question. But the thing is that if you run up the temperature too high, not really much will survive anyway. You get a situation where these composting facilities, especially the in-vessel ones, they'll basically allow the temperature to go up to 80 degrees plus, and then they'll pasteurize it. So they'll basically get the temperature go up even higher to like 110. And so you're cooking it, like you're with boiling water basically. So nothing will survive. And so the material then that comes out is very limited. And so that's why when we compost, basically, we really don't allow the temperature to go up further than 70, 75 degrees C. And that's already quite high. So, and then so what we're trying to do is we're trying to grow out the microbes that we know are the good microbes, so like after the heating session. And if you look into for instance, this is the interesting bit. If you look into Paul Stamets' book on growing gourmet mushrooms, there's a whole chapter on composting, and it's not to grow out the mushrooms, it's to sterilize the substrate for the target mushroom to take over after composting.
Right. Mm-hmm.
So it's so basically, the process is you kill the competition and then you reintroduce what you want to grow out, really.
Mm-hmm.
And because the hot composting that we do in piles only reaches that hot temperature on the inside, and you never have the guarantee that all parts will ever get through that, because we're doing things by hand and it's imperfect. Then even without inoculation, you do have a chance of getting some bugs surviving the process and repopulating. But it's about lowering the pathogen load in overall, and then the good guys basically take over the pile, and they create competition as well.
But if you're also doing aerobic composting and keeping the thing aerobic, that is keeping the microbes that you don't want, that tend to be anaerobic, sort of subdued in some way.
Yeah, I mean, yes, for sure. I wonder, this is exactly, what Dr. Ingham tells us. I don't know, how simplistic that is. There are microaerobic, bugs that are beneficial. And so, it's interesting to think of these processes. What is it that is actually growing in these piles when the pile is big? You don't really have a lot of high nitrogen materials, and the temperature still goes up. What is it that they're feeding on exactly? And I had this conversation with Dr. Ingham on Friday, actually, and I hypothesized that actual nitrogen fixers live in conditions with small amounts of oxygen. They're actually aerobic, but they're microaerobic. And so, the pile might have just enough oxygen for them to be happy, but on the other hand, they're still able to take the nitrogen and actually take the atmospheric nitrogen and actually then convert it into ammonia. So, but again, it's very simplistic, but I guess, the heating phase is something that we basically just take the analog from cooking. That, if you basically keep the temperature above 55 degrees C for long enough, then pathogens die, because this is simply the cooking industry.
So pathogens die, but also the good ones must die too. No?
Yeah, I mean, again, I don't have the answer. I'm not, I don't know enough. What Dr. Ingham tells us is basically that the good guys have means of surviving that. But when you look at sort of the Paul Stamets' book on growing gourmet mushrooms, composting is a way to sterilize material to then re-inoculate with your target mushroom that will take over the pile. So it really is a process that should be basically lowering the pressure from most sort of microbes in a certain temperature range, maybe, because the temperature goes up and it's basically different microbes actually doing the job. So then once they run out of resources, the temperature goes down, and these guys go to sleep. And then basically now the pile, what has it been voided now of other stuff? Or is it just some, some guys that only that survive that process are start coming in? Or is it that the material is now ready for other things to be put in it? And then basically they flourish because the community is not there anymore. It's gone through that, heating phase, which basically, created that disruption. So I don't have the answer, but it's interesting to think about that.
Right. Mm-hmm.
But definitely, composting is a process of processing the material in a way that allows us to grow out target organisms, and we basically sort of reduce the pathogens, and then we grow out the target organisms. But it's really in the maturing phase that they repopulate the pile.
So when you're doing your compost, do you re-inoculate the microorganisms you want to grow, or do you presume that they've survived and that you give them the
Bit of both.
The conditions for them to regrow?
Bit of both.
Right. Okay.
Bit of both. And it seems that across the board, we seems to be getting the most diversity from piles that are maturing with composting worms.
With worms that are added, you add the worms to the
compost. Or they survive the hot composting in the edges.
Right.
And they just repopulate the pile throughout.
The worms could move to the edges, couldn't they?
Yeah, they do. If you start
out of the heat, and then once the heat's died down, they'll move back in again.
Yeah, it's something that you can't do in an in-vessel method.
No.
because you're going to want to have worm jerky, but or worm stew.
Yeah.
But definitely in open composting, you do have basically the worms just moving to the outside, and then they love it in the winter, basically, when when you're starting with materials that already have worms. They just basically hang out right next to that warm center, and they just sit there for as long as they want to, and once the temperature goes down, they go inside, and there's so much bacteria for them to eat, they'll just go through that pile very quickly. So yeah, inoculating with stuff that is good, is
if you've got a good compost, you use that to inoculate a future composting pile.
Yeah, we always do.
Yeah. Yeah.
We always do. We would add some goop, basically we literally
like a starter, isn't it? When you've wiped the slate clean, or as clean as you can, and then add your starter with the positive biology that you already know you've got.
The best example, this is something I talked about as an idea for you, last year. The best example is Robert's compost, which gets up to 80 degrees. And so it's quite clean.
Yeah.
There's bacteria, but nothing else. And so we've seen our microbes just go through it like lightning, just goes through the whole thing and repopulates the pile, in a matter of weeks.
That's when you put your microbes into a solution and wet that stuff in that solution.
Yeah. Because that's the easiest, because otherwise we would have to basically turn it. So, but yeah, you can also just mix a bit of the compost that already has the microbes into some other compost, and basically if there's bacteria, and there's bound to be bacteria in that compost, then nematodes, protozoa, they'll have plenty of food to eat. And then when the numbers of bacteria go down, and you still have lots of carbon rich materials, then you've got now a niche for the fungi to start repopulating. And really, so I just updated the compost leaderboard. We've just had some samples sent in by Matt Fisher, and he's vermicompost basically has got one of the highest fungal counts now. So and so all of the other elements are actually quite high as well. So this is we've got there's more and more evidence that if you want to basically grow out that soil food web, in your own conditions, then the Johnson soup bioreactor with worms, or basically vermicompost that you feed yourself, that basically seems to be the way to go.
Yeah, so the vermicompost plus time.
Yeah.
For the fungus to actually develop.
Yeah.
Right.
Time is definitely a consideration here.
Mm-hmm. Hi, John. I'm taking over the conversation here. Sorry. Ask your own questions if you want.
That's why I was enjoying listening to the conversation. That's good. Yeah, it's interesting because we're trying quite a lot of different experimentation with the thermophilic stage and what we kind of add in. So we've played about with EM because we've just moved our site temporarily, started a compost pile, and you were mentioning as well before about not having a lot of nitrogen rich material, but the compost pile kind of just it gassed off so much we lost maybe 20% of the volume in a couple of days, and this was only 3 weeks ago. And I'm not really so the thing I'm realizing is it's all experimentation. I mean, this pile we're doing now is probably going to turn out differently than the pile that we sent to you, the sample. Yeah, I think it's just such an amazing thing to get into, because we obviously have people like Dr. Elaine Ingham who's been doing it a long time, and obviously the Johnson soup bioreactor. But I think there's just so much space for so many different alternative ways of doing this. I'm just really excited to kind of be on the compost train. It's
good. It's good. The thing.
No, go ahead. Sorry.
I think I'm hearing myself. So. When oh, there you go. Thank you very much. The thing. So that we need to start moving into now is trials. So obviously, it's good that we see more and more people having good results now in terms of the morphology results. You have the microbes. I'm actually going to share my screen and show you what it looks like right now. I mean, look at this. In terms of fungal results, out of all of the samples, basically, I haven't added all of them, but more and more samples are coming in, and we've got all of these fungal counts in the green, and that basically shows you that that there's more and more people out there who are actually doing something right. Maybe it's an accident in many cases. It's not sort of pre-planned, but they're getting to good results. And so if I get this by fungal to bacterial biomass ratio, what is it, Z to A? There we go. Then you've got good good numbers across the board, and that basically tells me that there's a good chance we've it's achievable in the UK, even on a smaller scale, for people to do this. That's one. But then basically this is the case of doing the controlled trials. I like Judith's approach in terms of how she's thinking of this. I've actually begun thinking of doing small parcel trials on smaller plots. And so if anybody's got any ideas for trials, we've got some land basically where they can do 3 by 6 meter plots, things like that on a controlled basis, and you sort of record experiments. That's something that's interesting to me right now. And we've sent out samples to Sheffield for DNA analysis. So we're waiting for that to come back. And so then we'll basically begin to have a much fuller picture of this whole thing. So it's really great that, you know, you're developing your own compost, you know, Phil is making his own compost, you know, and we're getting these things sent in, you know, and the results are actually showing that there are people who are actually getting some good results there. So now I think, you know, this is the time where we can start moving into having some experimentation done. And I think DNA analysis is going to be most interesting. I'm going to shut up now so you can ask a question. I think that's why you're unmuted.
I was just going to say, Daniel, that I'd be happy to be involved in any of those small trials. I mean, there's 3 of us doing it, and we're all so focused on creating. We want to create the best compost in Essex, basically. That's our goal. So obviously it's a big goal, but you know, and everyone I'm talking to is starting, you know, just members of the public. If I have conversations with someone in a shop, people can start to get it. And I think with all the madness that's going on in the world at the moment, compost is the foundation of everything, right? I mean, it represents our contribution to the soil. And I think it's, you know, I can really feel there's starting to be a greater understanding of how important this is. And so, yeah, like everything we're doing, I mean, I want to contribute in any way I can, basically, to kind of get things moving. And so just say a word, man, and we'll be up for it.
Cool. Super. Richard, how you doing?
Yes, good. And you?
Smashing. I'm just, you know, always trying not to go insane. Thinking about other 5 things I need to do next. This week I'm just playing catch up all week, basically. So if you got any questions, you only have got me to help out with it, because Adam is basically tied up with samples. We've got inundated with samples this week, so we've got stuff to do.
That's good.
That too. There's samples that are also have to do with the research at Sheffield, which basically means, you know, that they're not paying us for that. It still has to be done.
That's even better than Daniel, isn't it?
Just a quick question, if that's okay. Don't know whether you got any thoughts on this, Daniel. We bought a second-hand front sprayer tank so that we can try and do our rip and drip thing. Quite a lot of chemical residue in the sprayer tank. Obviously, we're trying to wash it out as best as we can. Any other ideas? I was thinking about putting some lab in it with some humic acid and just bubble it for a while, but just to try and complex some of the chemicals. But have you any ideas?
You know what? Good question. I mean, it depends if you've got actual solid residue, you know, on those walls. Because realistically, the only thing you can do is actually properly wash it. And because it's an enclosed tank, you've got a bit of a challenge, because, you know, when we work with IBCs here, we usually are able to cut off the top, and then you can simply scrub the inside. But you know, putting a thing on a stick and actually going to town with a stick, you know, trying to do it that way, you know, actually rub the sides. That's one of the things to consider, because you really need to
the best cleaner for chemical, believe it or not, is Roundup, glyphosate.
Is that right?
Yeah, it's far better than All Clear and all of those. It cleans it up. Whenever you've got a problem with nozzles and stuff like that, it's normally glyphosate that brings all the caked off stuff and blocks your nozzles up. So it's normally glyphosate that's a good cleaner.
There you go. Don't Bayer, don't listen to this. You know, you don't have to make it into a cleaning product now.
Who said glyphosate wasn't useful?
Oh,
Thanks for that.
No, well, I mean, leave it in there to soak for a few days, and
Yeah.
before you need to, don't waste the glyphosate for goodness sake. But before you're going to go spraying something with glyphosate, leave it in there for a few days, and then drain it out, wash it out, and there you go.
No, I'll have a look at that. We haven't got a lot of glyphosate on the farm, being an organic farm, but we
Or a neighbour.
Yeah, exactly. I might have to take it away somewhere.
Yeah, well, yeah, but
Absolutely, but no.
that'll clean it up better than anything.
Cool.
Scrubbing away with glyphosate. Never heard about that. There you go. You live and learn.
No, just leave it to soak, Daniel. That's all you need to do. You don't need to scrub it or anything else. It gets into the chemical formulas and just bites away at it. And so when quite often people who are not 100% with their sprayer cleanliness will have major filter problems after they sprayed glyphosate, and that's why it sort of releases the caked on chemical in the pipes and in the nooks and crannies where liquid takes the fastest route, and all of a sudden you get blocked nozzles and everything else.
Wow. That's another thing. Yeah, live and learn. No, that's fantastic. Interesting to know.
But it doesn't help an organic farmer. So no. I'm sorry about that, Phil.
No worries.
So next time you're buying the next tank, basically just ask the farmer to sell you the tank after spraying with glyphosate.
Yeah, maybe you should have done that.
No, we know.
Yeah.
Yes.
Where was this advice 3 months ago?
But if you'd have asked the question, Phil, we would have known.
My fault. Hands up.
Own up to it. No,
exactly.
That's very good. That's very good.
Because there's bound to be a detrimental effect to biology for chemical residue on the tank. I know it'll probably end up coming out eventually, but there's bound to be a detrimental effect. I wouldn't say it would kill it all, but it's bound to do something, isn't it?
Yeah. So glyphosate is one route, but if you can reach whatever you can reach, with a good scrub, on a
yeah.
Just do that. Really, it's just like doing the dishes. It's just more difficult.
Has it got a chemical rinser in there anyway, Phil?
Yeah, it has. I was trying to think what it is. I mean, we're not conventional farmers anyway, but there's some. I think there's some fungicide you use on potatoes. It's a powder. Is there? Wow. To me, it looks like that, and it's probably not being properly dissolved, if you like, and I don't know whether this. I just bought this thing at auction. Whether it had just broken, and then they thought, oh well, just leave it in the corner of the shed, and then they sold it because the pipes were full of it as well. It's like a grey, a greyish brown something. But
does it have a washing system in the tank? Yeah,
it does, but it's almost too caked on for that. I've been at it with it's an old thing as well. It's probably 15 years old. It's an old gem front tank. But yeah, it'll do hopefully what we want it to do, but it'll just take a bit of getting right. I have been scrubbing it and power washing it and stuff, but yeah, I was just looking for the miracle cure, and turns out it's glyphosate.
Yeah, well, see how we get on with it.
How big is it?
1,000 liters.
Decent.
So
how are you going to be what are you doing for the distribution, basically the pump and the system? Are you building it yourself? Are you getting some local company to make it? Are you buying it? What are you doing with that?
So the front tank, it's got a centrifugal pump on it, which isn't the greatest pump for biology, but at least it's a pump. So we're just going to pipe that back. And the good thing about a centrifugal pump is, correct me if I'm wrong here, you can almost stall it, so it doesn't matter if the liquid isn't going out as fast as the pump would like it to. It copes with that. So what we're going to do is just pipe it to the back underneath the tractor, put it into a manifold, split it there, and then just put like stainless steel pipes down the back of each leg and drill some holes in it. That's the theory.
No, that makes sense. So you're going to be doing it yourself. No, that makes sense. If the tank's got a pump already, then you don't have to mess about much. But it's, if you've got the resources to do all the piping yourself, obviously. Some people won't. Adam just popped in, did this because he's on the microscope, and suggested citric acid if anybody's not tried it yet. So obviously, there's things.
Thank you.
Citric acid is something that you can buy on eBay in a 10 kilogram bucket, for like, I don't know, 50 quid maybe or something like that. It's not expensive.
No, I'll try that. Thanks, Adam.
We've got a bucket here as well. What else could you use? I don't know. Whatever dissolves these things. Glyphosate. Use glyphosate. I heard it somewhere.
I have a patent on that. It's very expensive stuff now, isn't it?
Richard, be a patent troll and patent glyphosate as a chemical spray.
I don't want my name associated anything to do with glyphosate. I want to get away from glyphosate.
Just basically troll Bayer.
No. Yeah. How are you going to control the flow of the liquid to the leg?
Just by I'll put like a 10 mil or 12 mil, probably half-inch stainless steel pipe down the back of each leg, drill like a 1 mil or 1.5 mil hole in it. Well, 3 of them, like top of the leg, bottom of the leg, middle of the leg. Yeah. And then, to be honest, I'm not that worried about flow rate as long as the tank isn't emptying every 50 yards. As long as it goes a decent amount, I'm not worried about a flow rate.
It's that it's those holes that are going to dictate your flow rate then.
Yeah, exactly. That'll be the limiting factor.
But also you ought to have a look at, because you get different discs that you can put on there, so it'll give you the resistance to stop the liquid going too fast, if that makes sense.
Well, in the manifold, in the manifold you could put those in. Yeah, definitely.
So you say that pump, all it wants to do is just chuck it out as fast as it can pump it. So it needs some kind of resistance, doesn't it?
It's about the
size of the holes.
Like the hole size it's just like if you basically look at your all of the holes that you put into these tubes that you want to put at the back of the drill. You could literally just do a calculation of the area of all of them, and if it matches the area of the orifice on your pump, then basically there's nothing stopping the flow. The flow is going to be the same. So it's going to be sort of like in each cross section, you're looking sort of like at that area, and so that is the restriction of your flow.
Yeah, no, definitely, because it's it's just a Spalding's flat lift. It's only a 3-leg one, so essentially I'll probably only have 9 holes to start with, and then try that, and then if I need more sort of liquid, then I can drill more holes. But what do you think you should be aiming at application wise, Daniel? That's probably a needle in a haystack question, is it?
Great question, and it's something that we really have no clue yet. And the thing is that there's reports of so varying like application rates from all over the world, and we've only sort of stuck to about 70 liters of compost extracted per hectare, which basically means like you take 70 liters, you can extract that into 1,000 liter basically, and put that 1,000 liters on a hectare, because we go by the amount of compost, not the amount of fluid, because we want the microbes. We don't care about the fluid. So it's at the moment it's anybody's guess.
Yeah, and I was thinking I'll have to put an air bubbler in it as well when I got a 12-volt air bubbler.
But why do you need it?
Just to keep air in the tank.
Well, how long are you going to keep it in the tank?
Well, this is it. I mean, I suppose, what would it take to do a hectare?
Look, if you
an hour?
Will the pump be used just to pump it out, or will the pump be doing some recirculation as well?
No, I was just going to pump it out with a pump.
Okay.
You want some circulation because that pump will be capable of delivering around about 200 to 300 litres a minute.
Okay. So
So
it
you're
would be
gonna
better
want-
recirculating it, and then I suppose that would oxidate it then, wouldn't it?
Well, yes, that's another thing. I was just actually thinking, because when you describe this whole thing, right? If this is all like in my mind, if this is correct, and this is me speculating, so you need to really look at this in practice, like run the pump and see how it behaves before you sort of build the whole system, because then you don't get any surprises at the end. Because when you describe this thing, and when Richard says that you can deliver 300 liters a minute, and you put 9 holes, those, first of all, the first thing that comes to my mind, those jets are going to be like cutting
Super strong.
jets. You're going to be basically, and you're delivering this straight into the soil, and so any microbes that are going there basically are going to be hitting at a very high speed.
Yeah,
So
but that's where. Sorry, we can reduce that in the manifold, that pressure.
Yeah. Okay. So if you can do that, you do that. And
Yeah.
if you can sort of, use the manifold, for instance, to return some of that pressure into the tank, then you've got your recirculation. There is a thing about recirculation, and this is why your idea about the bubbler is also a good idea. It's not necessarily that you need the recirculation, but these microbes will settle in a matter of minutes in the tank. And so what you're going to end up with is you're going to basically be ending up microbes being put out on the first third of your hectare, and the rest will get water.
Yeah. Okay. So we want to keep it moving, huh?
Mm-hmm. And so, the sprayers, obviously, that we've used so far, they always got the recirculating pump, and we're very happy that it's on.
How many outlets did it have when you bought it, Phil?
Well, it was just the front tank, so all it's got is like what would it be, a 2-inch pipe that runs to the back of the tractor.
Yeah. Well, that's going to deliver. I mean, that pump's probably capable of spraying 100 litres per hectare through a 24-metre boom, with recirculation going back. So 9 small holes, that's going to be blasting out of there, and you're not really going to get up to pressure to be able to keep forcing it through.
Yeah.
You almost want a dribble rather than a squirt. If that makes sense.
I wonder if you could, because if these pumps, they often sort of like get controlled with the actual nozzle size as well, right?
Yeah.
But can't you, Richard, correct me, can you sort of, would a valve like Phil is basically considering, sort of reduce that pressure as well?
Well, I mean, that pump's probably way over what you're actually wanting, to be perfectly honest. I mean, FlowJet would do a little electric pump that would deliver everything that you want from the flow side of things.
Yeah, it might be easier just getting a 12-volt one.
Yeah.
Okay.
And controlling that with a pressure gauge. If you have a FlowJet, that'll work at a certain pressure, and it'll cut in and out to keep that pressure up, and then do the air pump inside the tank just to keep it alive like that. That might be an easier way than having a whacking great big pump putting pressure. If you've got a 2-inch, I'd leave your 2-inch pipe on the way through, so you're getting plenty of head, as it were, to the back.
Yeah.
But then just look at a small electric pump that's capable of delivering, and you need to work out what your forward speed was in order to have the correct amount of feed coming out of those nozzles. It will be a bit trial and error.
Yeah.
But that'll be a far more efficient way than having because you imagine you've got all that liquid coming through those pipes.
Yeah.
And then all of a sudden you're going to push it to the maximum with pressure. So it's going to, if you're pushing it to the back, it's got to be able to come back to the front. Whereas with the electric one, you're only going to take the amount of liquid that you need to keep that going, if that makes sense.
Yeah. No, it does. It's interesting what you're saying there, almost about a dribble. It might be as well that we limit it at the manifold somehow, and then put a bigger hole, or just drop different tubes, and it's just like a dribble rather than a jet, because that would just run through the soil better potentially.
Ultimately, when you, whatever, you know, you do, you basically just have to sort of, you know, put beakers underneath and just basically time your collection.
Measure it. Yeah. Work out what your forward speed is to your optimum application rate.
Yeah. Yeah.
I mean, what forgive me, what's the thought process to having 3 different depths?
Just to get the microbes all the way through the soil profile.
But with that kind of thing, you're making a leg where the subsoil is going anyway, that will naturally just follow that down, won't it?
Yeah, but my theory was that you'd have to, if you were wanting to soak everything, you'd have to put more down the back of the leg. Whereas if you've got 3 places, that'll give you 3 inoculant spots, which might grow into each other.
But knowing the way that some soil will smear around, you'll end up blocking those holes.
Yeah, we wouldn't be doing it when it was wet though. It would have to be pretty dry, just to crack rather than smear. We're fortunate we're not in a clay heavy area.
Yeah. Okay.
But yeah, it would want to be dry, I think. But one of the issues is with, correct me if I'm wrong here, Daniel, especially flagellates, if you're not burying them and keeping them moist, then they'll just die off real quick. They'll just dry out.
Yeah, they will. This is why, you know, when Frida starts, she already knows I'm basically interested in a project where she finds a good way of encysting the flagellates. So, you know, reliable way of encysting the flagellates, and then basically we just have a product and we sell people a product. It's like, put that onto your seeds, it's dry. It's like a bug in a jug. And then that could work with other bugs in the jug as well, because if you're adding, you know, a free living bacteria, then something needs to eat it.
Yeah, no, it makes a lot of sense. Because dealing with live biology, it can die so many different ways.
Yeah. So when you so you're basically going to have a drill which basically goes. I think he needs to take the phone call now.
No, sorry, it was just so you didn't hear it ringing in the background.
Okay, I'm going to ask the question then. So your drill basically is going to have also, you know, a bit of a subsoiler leg in front, so you'll be able to actually add the microbes below all in one go, which is actually pretty cool. Because we always thought that, you know, you have the subsoil first, apply the biology, and then 2 weeks later you would come in and drill. Is that the idea?
Not so much. Sorry, that was, yeah, it was Bayer. They were saying glyphosate's great cleaner. Yeah, no. What we're going to do, this field needs some remedial action. It was in broccoli last year, so it's had a lot of heavy traffic in the wet. So it needs remedial action. This implement that we're doing is just really like a subsoiler. We'll drill afterwards, but we're also looking at options that we can do with drills. So we are looking to pipe something up on a direct drill, and then with a different drill, we might just go with a sprayer in front of it and then drill.
Yeah.
So I don't know. I think 2 applications will be necessary.
It sounds like this is what we think as well. It sounds like what Richard suggested, you know, in terms of, you know, maybe changing over the pump. And if you don't have a recirculating pump, you know, your idea of aerating is going to be enough. But a recirculating pump to me is enough, basically to just to move the material around.
Okay.
My concern, Daniel, will be that it would be moving too much. You're going to have
it depends on the pump. The ones that we've had in the chafer sprayer don't bother us. We've tested material coming out of the sprayer nozzle, and we saw no difference.
Sorry, all I meant was you've got 200 litres a minute going to the back, taking what you want, and then you've got it coming back to the tank. So it's going to shake that tank up fairly well.
You'll probably have 170 litres going back to the front.
Easily.
A minute. Mm.
That's why just having it could be as long as you're not starving the pump, and I would suggest you want to have the pump at the back close to your subsoiler. As long as you're not starving that of liquid, that would definitely probably be your cheapest way, rather than trying to pump it backwards and forwards.
Yeah,
I'm not exactly sure if I understand it properly, so I'm going to try and word it, and you tell me if I got it. Is this a suggestion basically to keep the big pump and then sort of have a return at the squeeze point, basically, so that, you know, like whatever the reduction of area is, you have a return, and then basically, you know, the stuff that comes out is limited, but then you've got a return to the tank. Is that what it is?
If you have that big pump,
Mm-hmm.
you've got to have a return. Otherwise, you're going to shove all of that out through those holes,
Exactly.
and you'll blow pipes out. And that's what I'm saying. If you have a very small, sort of 30 to 40 litres per minute, depending on what.
That.
Exactly.
So then the idea would be basically to have that smaller pump, but then beside it, you would need to have some recirculating pump, correct?
Yeah, either that or the air for the tank to keep
or the air for the
aerated.
tank. Yeah.
Forget about the big pump.
Yeah.
But I mean, depending on the size of Phil's drill as to whether he would need that.
Because my worry with the big pump, you know, if you basically work with the idea of recirculating that, then you're adding sort of kinks and places where the microbes can basically die in the tubes.
Yeah.
So you're basically, you know, whacking the microbes all across the system, you know, in many places, so they could get, you know, quite damaged.
Yeah, the idea was that we could kind of make it so that we could plug this front tank setup onto the subsoiler and the drill.
And just drill.
So we'd need more, obviously, as you said, Richard, we'd need more. Well, it's only a 3-meter John Deere 750A. What is there, 32 cooters or something on it?
Yeah.
So obviously we'd need more pipes on that than. But
unless you had a small tank, and you basically have, you know, one pipe just feeding the small tank from the big tank basically, and the small tank simply drips.
Yeah, the issue with that is you end up getting it goes through some pipes quicker than others because they're not all the same length and stuff like that. It's always better having a bit of pressure and with resistance, I think. Is that right?
Yeah.
There you go.
How are you going to apply it in front of the sprayer? On pipes the same, or as a spray, or what? What you
say that again? Sorry.
How are you going to apply it down tubes in front of the coulters, or?
Yeah, so it's similar to the. I mean, a lot of the 750A modifications, like something similar to the fertilizer applicator, liquid fert applicator. That's what I'm thinking, which is essentially just puts it in the slot, I think, just behind the disc before the cooter.
I mean, I don't know, you probably know more about this than I, Daniel, but people are spraying it into the air induction side of air drill, aren't they? Are they these teas?
I've not seen that yet, but it's actually a very interesting idea, because then basically you've got all you know, you're passing the mechanism, which means that you're not clogging anything.
And also, it's been applied to the outside of the seed as it's going down into the coulter, so you're getting an even distribution of it.
Yeah.
Yeah, because the idea would be we'd coat the seed as well anyway.
Yeah.
So there'd be a seed coat. This would just be essentially like a wee bit extra in the sort of furrow.
It's interesting that that recently, so whatever we're doing here, not with wheat or barley, but with vegetable seeds, we're seeing seed coating actually delaying germination.
Really?
Mhm. Not necessarily delaying the growth of the plant, but just delaying germination. So I don't know. It's interesting. It's interesting to think about these things, and like having perhaps more smaller experiments.
And what are you
Sorry.
putting in as a coat? Sorry, Richard.
Goop.
Is that goop?
So it's it's interesting basically that we would need to like all of these questions, right, that need answering. It seems that that's one of them now.
Yeah.
Because there's many different people who have many different sort of experiences with this, and I've heard it from, I can't remember, maybe it was even John Haywood, but somebody was also confirming that too, that they were getting a delayed germination. It was better germination rate and better growth, but delayed germination.
Mm-hmm.
So it's interesting. I definitely I definitely would want injection into the soil through the compaction layer, because that is the one thing that's the only thing that we know to try and alleviate compaction. We have nothing else to do beyond that. And then basically have some foods to keep these guys going whilst the plant is putting its roots down. And then basically have soil drenches, and I just don't know enough about what's going to be the effect of seed coatings, and I think different microbes will have different effect on germination.
Yeah, absolutely. You're almost kind of, you could be lucky, you could get some microbes you want, you could be sort of, it's a bit of a machine gun approach. But
well, I'd like to get to the point where we're not lucky, but obviously at the moment we're just trying to throw everything at it, and
hope something sticks.
Yeah, so let's see what Sheffield comes back with DNA analysis, because we've sent 12 different compost samples, basically all of them.
How soon will you get results?
Pass.
Okay.
It's university,
Yeah. They're on holiday till December.
They just basically do it at their own pace, and sometimes it's very, very fast, and sometimes it's like, yeah, let's wait for some other things.
Mm-hmm.
So yeah, so they've got the project is going now, so obviously they'll probably have to finish it by the end of March, so probably not later than end of March we'll know something, but we still have to wait for that. I'd love to have our own DNA machine here. That would be nice,
wouldn't it?
If you're doing DNA analysis, surely you need to do it there and then, or do the bugs not eat one another, or think the composite, because it's biological and live, or do they freeze it, or how does that work?
They extract the DNA and they stabilize it. They've got chemicals to do that. So they receive samples and they process the samples in a way that basically stabilizes the DNA.
Okay. Right.
That's all I know.
Yeah.
I really don't know anything about this. It's like I sometimes ask Helen about, so can you explain to me? It's like, oh yeah, it's like you go through this, that, and those. It's like I got lost 3 sentences ago. So
yeah, it sounds like me and our son that works in Cambridge. I just He sent me a paper this week, and I was at my dad's, so I read it when my dad was asleep. And I said, yeah, very interesting. I think I get the gist, but I'll reread it with a dictionary beside me. Yeah.
Yeah, quite often, I read these papers, and so it's kind of like a ratio of scientific speak to English language that sort of prevents you from understanding anything, and you sort of have to skim through it, and then maybe one day you understand 5%. Anyways, more questions, because it's been an hour, believe it or not. It was an interesting conversation from the perspective of that applicator, Phil, and thank you, Richard, for that input as well.
Yeah, thank you. I'll keep you posted if you care. If you don't care,
No, it's interesting. It is interesting.
No, definitely tell us.
Something I've been bumbling about in a wee quad bike with a 250 litre thing behind me, but I mean, we rinsed it out and did the best we could, but somebody, and it was before, I think, before we were talking in the way we have been late, on these Wednesday afternoons, somebody said, just put biology through it a couple of times, and actually that can deal with a lot of it. You'll lose that application maybe, or some of it, but in the long run, that'll do the job. So I don't know if that's another option other than using glyphosate.
Well, this is what Phil was suggesting in the beginning. So, maybe adding some lab or whatever.
Yeah.
There is that, basically if you were to play around with it in a similar fashion to what Adam's doing with the mineralization tank, if you're planning on putting a bubbler into it, why don't you just put it on a static bubbler, basically add a bit of compost into it and sort of make compost tea in it and see how it behaves.
Yeah.
And if you've got your microscope already, you'll be able to see the change, right? And then will that lift some of that? Missed this one. He's just passing by. Will that lift some of that crud as well? So
yeah,
you can try it out. You can play about with it because it seems that
equally so with the pump you've got on there. If you slow it down, I don't know whether it's hydraulic or whatever, but if you slow it down, that's going to get it working through the pipes as well, and perhaps adjuvate it with the pump you've got.
Yeah. No, it's just a hydraulic pump, so there should be scope to screw it down a bit.
If you slow it down, it's all going through the pipe work of it, as well as doing the air rate. Would that do any damage to them, Daniel?
Explain that to me again.
Well, basically, the big pump, instead of pumping it to the back with the nozzles, effectively put the pipe back into the top. So it's just going around circulating. Obviously, you're going to have a lot more disturbance than you would do in a smaller pump.
Well, as long as you're not pointing the tube in a way that's simply just making the microbes hit something, at a very small distance.
Yeah.
That's the thing. So if maybe the jet of water is actually inside the water, then basically it just then recirculates. But if you're smacking it into the surface, then that's questionable.
Yeah. But that would be sending all the liquid and the microbes all around the whole system then, rather than just within the tank.
Yeah, exactly, because there's bound to be sediment and stuff everywhere.
Yeah.
You need to watch your filters; they'll get clogged up in no time.
I take all the filters out.
Absolutely. Yeah.
Yeah, like the sprayer we use is it's just like a really old it's only a 12-meter thing. We use that because we sew with 12-meter tram lines because we've got a tine weeder that's 12 meters. So it's literally, the sprayer has like 190-degree bend on it, a manual thing to just so that we're reducing the complexity, and there's no filters. There's 190-degree bend. All the rest are Ys and 45s and straights, and there's not even a manifold on it. I've just got a big sort of valve that I can half open it, and it works fine. But I think you might as well just try and make it as easy as possible. And for me, I never turn it off at the end either, because you can't overdose biology.
Not really, no.
If you can, I'd like to know how.
you need a lot of it for sure.
And the end rigs, well, headlands, you'll probably call them. They're all the most sort of degraded anyway. So I always think, well, you might as well double dose the end rigs.
Double dose the what?
So sorry, that's a Scottish term, is it?
N-rigs, the bit down the outside of the field where you're doubling over all the time when you're turning, and
you'd probably call it a headland.
Yes.
There you go.
Over here is headland, yeah.
Yeah.
Your headland is the biggest part of the field.
Yeah, absolutely. Especially if it's full of gushets.
What? You're doing this on purpose now, Phil. I'm
there's
gonna
a
end this.
ter-
I'm gonna end this humiliation. Okay.
Yeah.
there could be a multitude of different things to call those corings, and God knows what. Everywhere you go, there's a different terminology.
Great.
That's it.
So I'll see you. Right. Bye.
Okay, guys. Then see you later.
Cool.
Thank you.
Thank you. Take care. Thank you, guys.
Take care. Bye.
Thank you.
Take care.
Take
Thank
care.
you, guys.
See ya.